Thanks so much for coming to our talk today on ML engineer versus data scientist. This is one of our panels in the ML Observability Unsummit hosted by Arize. So today, we have a group of ML engineers and data scientists who are here to help us answer a question we hear all the time. Who owns a model once it's actually deployed into production? Who's responsible for models as they're in the real world? And so we thought we'd have a panel and a conversation with folks who are actually doing that today and hear their insights. So let's get introduced. Irving, do you want to go first and say hello?
Hey everyone, my name is Irving. I currently work in data science and growth at Slack, and I used to be a data scientist and an ML engineer at Facebook.
Awesome. Nate, would you like to go next?
Sure. Hi, I'm Nate. I've done mostly backend engineering in my career. Most recently, I was at PagerDuty for about 5 years, doing all sorts of things from backend to working full stack to a couple of years working on an ML feature team and doing ML infra as well. And now I'm at Arize.
Awesome. And Romi, we're lucky to have you too.
Glad to be here. So I used to work at Pinterest as more of a product engineer and joined DeepScale working on ML infrastructure and data management. And now currently work at Tesla working on infrastructure. So
awesome. Awesome. Well, thank you all so much for joining us today. So let's kind of kick this off. I think one of the questions we hear and get asked a lot is, there's almost this lack of definition between, what are the responsibilities of an ML engineer versus a data scientist? There's some companies like Google who have this you build it, you own it approach. Everyone's an engineer, you're a full stack data scientist. And then in other orgs, you have this kind of separation of the data scientist versus the ML engineer. What do you guys think about, what do you guys, how do you distinguish between those two roles today? Anyone can take this one. Go for it, Irving.
All right. So I would say the term data scientist is usually pretty overloaded in industries nowadays. So data scientist at one company can be a product analyst, could be a research scientist at another company, a business analyst at another company, a statistician at another company, and a full stack, ML engineer at another company. So it really depends on the type of the company. For earlier stages, for a company that's in the earlier stages, data scientists tend to be, as you mentioned earlier, a part of quote unquote full stack, meaning they own everything from model production to implementation to infrastructure development to model monitoring and deployment to exploratory data analysis, like the full wheelhouse. Whereas ML engineers almost exclusively have an engineering background or computer science background. So they're the ones who own the implementation of the models, who tune the models, and also infrastructure development, especially in larger companies, right? An ML engineer in a larger company I would say around 60% of their time just from past experiences spent on infrastructure work. Whereas data scientists tend to own the top of the layer at most companies, where once the data is in an analyzable form that's well modeled with a stable data infrastructure, they're the ones who sort of drive the decision-making behind the data for product direction and business strategy.
Do you think one's harder to get into? Like, do you think that it's harder to go from being a data scientist into being an ML engineer, actually have them write production code? Or do you think it's, it's harder to go from ML engineer and having to learn about all the different types of modeling approaches and, experimentation? I mean, Romi, you've done a little bit of everything. So like, what do you think?
Yeah. This is kind of a good question. And to be honest, the distinction makes me a little uncomfortable because I come from like a small software, like a small company background where, I was the 9th engineer at DeepScale, and we grew significantly since then. And there was never really like kind of a distinction between data scientist and ML engineer. You just did whatever you could to make the model better. Sometimes that would involve building infrastructure. Sometimes that would involve like managing data. Sometimes you had to write SQL to figure out what was going wrong. And other times you literally had to be a data labeler and you had to label the data because that's what actually improved the model. So you kind of need to do whatever it takes. And I think maybe the distinction might be clearer more specifically in product companies or larger companies, because I know in product companies, data scientists tend to be people who analyze emerging trends rather than building overall systems. And so they try to determine, okay, maybe approaching growth or approaching a product from a certain angle or a certain demographic might yield better results. And so I know that was very clear when I was at Pinterest. People kind of went along that track.
Mm-hmm.
But I've noticed in self-driving and in smaller companies as well, it's just like you kind of have everyone become an engineer building the infrastructure, tooling, systems, and AI systems to like get things to scale and deploy. So
do, do, do you think that there's enough tools to actually help, you know, data scientists move more into the infrastructure engineering world? Or, you know, do you think that it's a hard barrier to ask them to deploy production code?
it's definitely a huge challenge. We hit so many different roadblocks at DeepScale. There's just so many issues from the training side, as well as deployment, validation, data sanitization, data storage, just everything along the stack. And any kind of tools that you can add makes things better. So I know, for example, we built our own data annotation tools in-house, and then we eventually brought that out of house to Scale and other companies. We found training costs prohibitive, so we built our own data center on site, and it was actually pretty worth it, given that like 1 month of training costs paid for itself, paid for the cost itself. So.
Mm-hmm.
But you know, there's like a huge amount of cost savings possibilities there. Even for data management, we built all the tools ourselves. And if you consider the fact that we were a lean team of 10 engineers or so when I joined, and like around 30 or so when we got acquired,
So
it definitely slowed us down.
And were these tools built to help data scientists? I mean, are there tools that you used, Irving or Nate, on some of your old teams about to make data scientists, you know, transition into the engineering, you know, do engineering roles?
Nate, if you want to take this one because you haven't gone, feel free. I can.
Sure, yeah. I mean, I think one of the things, so in my experience, I worked in a fairly young ML practice, and so there wasn't a lot of developed tooling. And so one of the things we tried to do first was to basically take engineering oriented tools and make them fit for data scientists. And we encountered a number of barriers around that, which made it difficult for data scientists to kind of get more integrated into the engineering side. I think one of the other things that I noticed is that a lot of it has to do with prior knowledge and interest as well. There are some data scientists who are just not as interested in working on the operational side of things, but there are some engineers that are very interested in that. And so they'll be more of like a self-starter in terms of like, well, I can go ahead and maybe build out this full proof of concept that spans both my model and the integration of the product. And so there's a little bit of that too that comes into play, and that I think can be something that can be cultivated as well. But there's an element that I think each individual brings to that can affect whether or not they end up transitioning more into one or the other.
Yeah, I think I asked because, you know, I don't know if every company, you know, you think about 5 years down, is every company like an Uber or Google or Facebook going to have these internal ML infrastructure platforms? You know, Uber, for instance, we had built Michelangelo internally, and it 100%, you know, improved data scientists' ease at being able to build and train and deploy models without, you know, needing an engineer even in the loop. And so there's like this process of, do we think that these ML infrastructure platforms, whether it's end to end or there's separate vertical solutions, will help, move, these offline models that they're building into the online world faster? Or do you think there's probably going to always be these certain components that, will ask a data scientist to delve more into the engineering world? And that's kind of where I'm trying to get at, is like, will there always just be one person, this full stack data scientist, who now is able to deploy models with all these advent of tools, or will there always be a separation between kind of data science and ML engineering, or engineering as a whole?
I think especially in the early stages of a company, your early few hires who are going to be the ones setting up your data warehouse, writing those initial airflow pipelines and writing up, like a data infrastructure to get your platform going. Those types of jack of all trades people who can do both the data analysis as well as the ML engineering are going to be really important. And as the company becomes more mature over time, then we start to see greater differentiation of roles as roles become more specified. People can then specialize in just doing data analysis. Some other people who might enjoy data engineering more might focus exclusively on data engineering. And those who enjoy a hybrid of both might be ML engineers who also do data analysis. It really spans the whole spectrum. So I think to bring up what Nate mentioned earlier, it really depends on the data scientist's prior level of technical knowledge beforehand. So someone with engineering background can dive deep into the code base and make infrastructure changes that someone without that background, who maybe took a data science bootcamp to pivot into data science, that those types of people can't. But I would say once your company becomes sufficiently mature enough, it's possible for any data scientists, if they have the motivation and interest, to pick up some technical skills to learn how to write airflow pipelines. But in my opinion, that's no substitute for a formal engineering background where you can actually build a lot of those systems from scratch.
Yeah. Yep. And we saw a lot of that. Some of my old, data scientists from my team, had come from like Insight Data Science Bootcamp, and it's awesome being able to like take their background and maybe a physics, PhD in physics or PhD in chemistry, and now they're able to go do data science at, top tech companies. But there's still that barrier to kind of getting code in production, which I guess gets me to my next question, which is, what do you do when, Irving, you're a data scientist right now, you've built a model, you put it into production, you start to notice performance starts to drop. Who first identifies that in your org? Is it the engineer or is it you? And then who addresses it today?
Usually it's a combination of many different people. We see performance drop through our metrics, which is manifested through our experimentation framework. And usually the data scientist is the one that owns the setup of the experiment as well as the monitoring of the experiment, and owns the metrics dashboards. So usually the data scientist is the first person to know. At other times we have anomaly detection, so we can detect a lot of these things automatically. But it's a combination of the data scientists as well as the product manager or the engineering leads or engineering managers who are responsible for the rollout of the feature. So anyone can notice in any particular point in time, but it's going to be a higher likelihood that it's going to fall on the data scientist, just because they're intimately familiar with the workings of the model as well as with the experiment setup.
Got it. Okay. Romi, is that kind of what you experienced, or is that,
Yeah, so like, there's different kinds of performance, right? There's also like model speed, execution of performance. There's performance in terms of how well it performs in the actual classification of tasks and things like that. I think the thing for us is just really heavy on CI and CD pipelines. We have a lot of hardware in the loop kind of tasks to measure drops in performance, to measure drops in speed, and to consistently catch regressions. Mm-hmm. Our model itself, like our model cadence, is so fast that you don't really have the situation where a model's been out for a long time and slowly degrades. Yeah. And we don't have necessarily the same situation in social, where the model performance may actually cause like a bunch of other kinds of factors downstream in terms of other kinds of effects.
Mhm.
So we have kind of a different set of problems. But I think for us specifically, it's just being very intentional about getting a large number of suites of tests and metrics and being able to catch regressions in real life. So having a lot of telemetry on when there's interventions and telemetry on when there's issues, and being like eyes peeled on those dashboards. And I think everyone in general owns that.
Do you,
Yeah.
you know, I guess, Irving, do you go and set up that telemetry for every experiment or model that you deploy? Is that your responsibility?
If we had the tooling for it, then yes. But I would say in a lot of cases, our systems aren't as advanced. It's usually we monitor metrics as they're rolled out through our experiment dashboard. Sometimes we build custom dashboards for custom metrics that aren't available in our framework.
Yeah.
So it's more of an art than a science, I would say.
Yep. Yep. And Nate, I guess, for even like, organizations that are still kind of trying to roll out their first model or still building out that ML infra, does telemetry seem like, the last thing on the plate, like having that observability? Does that seem, I'm curious, at an org like PagerDuty, how would you have caught regressions? Did you guys have CI/CD pipelines? Was that in the roadmap, or just kind of further out in the scope?
Yeah, I mean, one thing that I really can't emphasize enough is to start with your metrics first and not just throw something out there and not really have a great way to understand how it's working, because you're going to get questions from customers, from stakeholders asking, hey, is this working the way that it should in this particular way? And without solid metrics, a solid way to solid telemetry, you're not going to be able to really give clear answers. Yeah, so in a younger kind of ML practice like the one that I was part of, yeah, I mean, there was, just to kind of go off of what Romi and Irving said, I mean, there is, ultimately everybody is going to be owning some part of the model. It's just a matter of what part of the model you're talking about. So if it's in terms of the actual like model metrics and the performance of it, it's usually the data scientist, just to reiterate what was said earlier. And then on the operational side, to make sure that it's not, it's not crashing, or, it's scalable and it's not slowing down in production, that would probably be more of an engineer's type responsibility. But I think there is also this one area where there's a possible opportunity for synergy between data scientists and engineers, where there may be some production related issues that cause adverse effects on the model performance. And so having that additional insight can help like data scientists understand the performance of their models, or be able to triage or debug their models more easily.
Like feature encoding pipeline breaks in production. Maybe it's the ML engineer who actually deployed that into production.
Right, but yeah, I mean, just overall the impact of monitoring models, at least in my experience, has been a really difficult thing, and especially in a younger practice where you're trying to you're trying to integrate these two different disciplines together, and you have a set of existing tools that are more fit for a particular purpose. And so there's a lot of, like what Irving said, like building custom dashboards, things like that, piecing together different parts of existing tooling, which may not be a great fit, but it's kind of what you have to work with. And so I definitely look forward to, as the years go on and the industry progresses, having better tooling in that area and other areas as well.
Yeah, it's almost like we've decided what the software stack was going to be over the last 20 years. And like this next 20 years is kind of defining the ML stack and what that's going to look like. Well, I have one last question that we've been asking kind of all of the different panels. And so I wanted to kind of ask that before we kind of close this out. This year and this last couple of years, there's been a lot of, interest in the tech community and outside the tech community on making sure that models and AI are ethical and fair. And there's been a lot of discussion about this. And, as day-to-day practitioners, sometimes those models don't even have, the models you're working on don't even have social implications. Sometimes, it feels so far out from what we're doing on a day-to-day. I guess question for you folks as day-to-day practitioners, how do you think about sort of, involving, other stakeholders as you're deploying models into production? Because it's not just your responsibility to make sure that, models are ethical, models are fair, and consider all of the possible ways that it potentially could not be. Are there business stakeholders that you guys are talking to or involved with? How do are there conversations happening about the ethics of models that even you're building? And anyone can take that. I'm gonna go ahead and pick Irving. Thanks, Irving, for being
I would say at Slack, definitely not so much, but at Facebook, definitely.
Yeah.
When I was in Instagram, I worked on the machine learning as a machine learning engineer, and being a very visual platform, Instagram is almost kind of like Pinterest in the sense that there's a lot of potential for very abusive content or very sensitive content. So we have what we call like a protect and care team or PAC internally that deals with applying machine learning in a way such that we remove a lot of this like negative content from our platforms. And even within that, there's another team that manually reviews a lot of content that comes in sort of as like a last resort. Because even though as advanced as our machine learning models are, they're not perfect. So I would say there is definitely a very humanistic aspect to this. And it's something that larger companies of the scale of say like Facebook or Google can manage, but we're not at that point at Slack yet, nor do our models really deal too much with like ethical issues.
Yeah, that makes sense. Yep. And I guess an approach is kind of having people designed and kind of focus on making sure that models are fair, like in that case.
Yeah.
Romi, any other thoughts on this?
Yeah, I know when we were at Pinterest, some of the things that we were considering specifically is like making sure that all our algorithms are neutral to skin color and have recommendations to people of all backgrounds and things like that. I did not work on those, but I know that those were things that the company as a whole discussed. And generally, when you have recommendation systems, these kinds of things are pretty important. In the context of self-driving, I think the industry overall is, as a whole, trying to get the technology to fruition and trying to get things productionized. And so I don't think we have reached the ethical implications yet because for the most part, the responsibility of all issues are on the hands of either the company that's controlling or operating the robotaxis, or in Tesla's case, the person who's driving the car. And so we've effectively sidestepped that entire problem by placing responsibility pretty clearly on the operators. However, I think this will be more of an issue when we actually have things fully autonomous and these taxis have to make kind of more complex decision making in a fully autonomous fashion.
Yep.
Yeah.
That makes sense. Thank you both for answering. It's a really important issue, and I think we're all going to be thinking about it as this next decade occurs. And so, as practitioners, we're building these models and we're deploying them to society, and it's important to think about as they get smarter, as the models get smarter. So with that, I'm going to say thank you so much, Irving, Romi, Nate, for being a part of this panel. Super grateful to have folks like you talk about what it's like to be a practitioner, what are the differences between data scientists and ML engineers. And, I thought this was a really interesting and insightful conversation. So thank you so much for being a part of it.